Hello again and welcome to this new section, Introduction to Artificial Neural Networks and TensorFlow. Let's see what we are going to learn in this section. Okay, in the first video we will give an introduction to artificial neural networks, which are basically computational models inspired by living brains. In the second video we talk about all the elements to consider when building a deep neural network model. In the third video, we change subjects and we talk about TensorFlow, which is the library that we will use to create these deep neural network models. And finally, in the last video, we will talk about the core concepts that we need to understand about TensorFlow in order to use this library. Concepts like variables, placeholders, sessions, graphs, and others that are essential for using these library. Now, please notice that this is a conceptual section, and in this section we will build the conceptual framework that we need to actually use these models in TensorFlow. So we will talk about the concepts of artificial neural networks and deep neural networks, and also about the concepts of the TensorFlow library. So this will be a conceptual section, and the next section will be a practical section where we apply everything that we learn in this one. Okay, so let's get started. We give an introduction to artificial neural networks. Okay, so this is the plan for this video. First, we will give an overview of these models that have become very popular in recent years, artificial neural networks. Then we will talk about perceptrons, which are the building blocks for artificial neural networks, and then we will see how we go from perceptrons to one specific type of artificial neural network, the multilayer perceptron. Okay, so this is the plan for this video. Okay, so maybe you have heard about these models that have become really popular in recent years, artificial neural networks. And these are biologically inspired computational models that can be used to train a computer to perform a task using data. So, as you can see, these models are part of the broad category of machine learning models. Now, the distinction between these models and others is that these models are based on a collection of connected units called artificial neurons. Now, there are many types of artificial neural networks, and in this course we will use one specific type, one that is called the multilayer perceptron, and please note that there are a lot more variations on artificial neural networks. Okay, now about the uses and applications of these models. These are machine learning models, and of course we can use them for classification and regression tasks. But we can actually extend these models and apply them to other very specific tasks like computer vision, speech recognition, machine translation, and many more. These models are the basis for the exciting and growing field of deep learning, which has been really successful in the last years in many areas of application. Okay, so now let's begin our discussion of these models with the basic building block, and these are the perceptrons, and these are the simplest type of artificial neuron that we can have. They were invented as a simple model for binary classification, and this is the way these perceptron work. So they are very simple models, and as you will see now. So let's use the context of dataset that we have been using in this video, in this course, about the credit card default dataset. So let's say that we have only two features for classifying defaulters and non-defaulters. Let's say that we have only age and bill amount. Okay. So the idea of the perceptron is to create some kind of a score. So you take one constant, let's call this constant W1, and then you multiply that constant by the value of age. And then you add another constant, the multiplication of another constant, and the value of the bill amount. So from this simple operation, we create what is called, or what we can view as a score. And then we follow the following rule to classify people as defaulters or as non-defaulters. So if this score is greater than some number, then we classify this person as a defaulter, okay? Now, an equivalent way to state this rule is the following. So the prediction of this model will be 1, or in other words, defaulter, if this quantity that we see here is greater than 0, and the prediction will be 0 or non-defaulter if this same quantity is less than or equal to 0, okay? And we call this value B as a threshold or a bias. Okay, so this is a very simple rule that is proposed by this Perceptron model. Now, in general, if we had n features, not only 2, then our Perceptron would look like this. As you can see, we have the same form. We predict 1 if, you know, the sum of these weights times the values of our features minus b is actually greater than 0, and otherwise we predict 0, okay? Now, assuming that all features are in the same scale, the weights will represent the importance of each feature in making the decision. Okay, so we know that for this particular problem, we have all features are in very different scales. For example, ages are in very different scales than bill amounts. But let's say that you scale all the features to a similar scale, then you can think about these W's, the weights, as the importance of each feature when making the decision. Okay, so this is the perceptron, and this is another way to visualize this perceptron. Okay, so you have the values of the threshold or the bias, and you have the value of h, which we'll call x1, and the value of bill amount, and we will call it x2. So these three values go to this. You can view this as a node of this graph. This is actually a computational graph. We will talk more about what is a computational graph when we talk about TensorFlow. But now you can think about this as just a way to visualize the perceptron. So you have the values here. These values go to this operation, and then you get an output. Okay. Now there is a little modification that we can do to the perceptron, and this is to add what is known as an activation function. So an activation function is any function that takes the result of this operation and performs some transformation to this value. So the input for the activation function is just this this quantity, the resulting quantity from this operation. And then after applying this activation function, we will get the output. So this is the perceptron. We can add an activation function to the perceptron, and then we get the rule or the classification 1 or 0. Now, maybe you are wondering, how do we decide which are the best weights and threshold for our perceptron? What activation function can we use? Now, the answers for these questions are provided by the Perceptron learning algorithm. So there is a learning algorithm that we can use to actually train perceptrons. Now the thing is that the good thing about perceptrons is that they are very simple to understand. However, they are very weak in performance when compared to more sophisticated methods, such as the methods that we used in previous sections. So it is not worth it to actually learn about these perceptron learning algorithm. However, these very simple models are the building blocks for artificial neural networks. And now let's see the motivation for artificial neural networks, so where they come from. Now, these are models based on perceptrons or other similar basic building blocks, but the ones that we will learn about in this course are based on perceptrons. So one of the most popular artificial neural network models is called the multilayer perceptron, and these are the models that we will use in this course. And the motivation is the following. Instead of using one single perceptron for classification, what if we use many? Now, since we know that perceptrons are really bad classifiers, what if we use many of them? So, if we use many perceptrons, the result will look like this. So, here we have 3 perceptrons. So, here we have the first perceptron. Notice that we have here a different bias. One bias for this perceptron. Here we may have another bias. And in the third perceptron, we have another bias. And of course, the values for our features will be the same in all the cases. Now, if we use 3 perceptrons, what we will get are 3 outputs, as you can see. But we know that this is a binary classification problem, so we need only one output. We need only one answer for our problem. Is the customer a defaulter or is a non-defaulter? So what we can do now that we have 3 outputs, we can combine these 3 outputs, or we can view these outputs as inputs for another perceptron. And as you can see, we can take the values, the outputs from these perceptrons, and feed them as inputs to another perceptron, and this perceptron will give us the output. Okay. So this is the intuition on how to build neural networks or multi-layer perceptrons, and this is an example of an artificial neural network. Now let's go with some terminology. What you see here is known as the input layer. So this is where you have the original data, the training data that you will use to train this model. So this is known as the input layer. The middle layer that you have, so these perceptrons that we have here are known as the hidden layer. And finally, the output that we get from the network is known as the output layer. So these are concepts that you need to know before start using this model. So we have input layers, we have one input layer, we have a hidden layer, and we have an output layer. Okay, so this is another way to visualize the same artificial neural network from before. Now this is a more compact way to visualize it, but it's actually the same network. So instead of having 3 biases, what we do is we add one constant feature here. This feature is always 1 for every observation. So now this value 1 gets multiplied by the different biases here, and in the case of the first one, this goes as input to the first neuron in our hidden layer. Now the value of 1, the value of x1 gets multiplied by some weight, and this goes as input for this neuron, and the same happens with the value of x2, gets multiplied by one weight, and then it goes to this first neuron in our hidden layer. The same happens with these other 2 neurons, and then the result of this is combined into a single, is used as an input for the last perceptron in our network, and this is the output. This will give us the output of our network. So this is how we go from from single perceptrons to multi-layer perceptrons, and this is the example of an artificial neural network, and this is the model that we will use in the following videos of this course. Okay, so in this video we talked about perceptrons as building blocks for artificial neural networks, and we gave an example of an artificial neural network known as the multi-layer perceptron, which is the basic model for other more complicated models on neural networks.